Okay, so we're taking a look at question 1 from the Calculus Chapter 10 practice test. And I've already gone and done a few of the groundwork here for question 1. If you take a look at this, we're looking for a series or where this series converges. And I always like to say that if it's a geometric series, I want to approach it like a geometric series. If you didn't recognize this as a geometric series, just write out the first few terms. Here I've written out there's first 4 terms, and from the first to the second to the third term, it's really obvious to see that this is a geometric series because we're multiplying everything by negative 9x squared every time. So that's my repeated ratio. The first term is 1. You should take note of that, but that's not really going to play an importance to question 1. So in order for a geometric series to converge, the absolute value of that ratio needs to be less than 1. So that's where our solving comes in. The absolute value of negative 9x squared needs to be less than 1. Of course, you can separate a product inside of an absolute value as negative 9 absolute times absolute value of x squared. Should be less than 1. And that brings us to x squared needs to be less than 1. Now, of course, x squared can jump out of that absolute value because x squared will always be positive. And I think I did some math fail. This is 1/9. Okay, and we're ready to go then. Once you take a square root of things, as I'm sure you'll want to do, the correct way to solve this, at least the way that we wanted to see you do this in calculus, is when you take the square root of an x squared, that is going to become the absolute value of x. And that just becomes the principal root of 1/9, which is 1/3. This way you make sure that you are accounting for the positive and negative roots here. So this says the absolute value of x is less than 1/3. If we put this to make it look obvious for those of us in calculus, then we'll see that the center of this series is 0. As you can tell by all the terms, the center is 0. And then the radius of this series is 1/3. And that's great. Now to finally finish this, find the values for which the series converges. That's almost code speak for the interval of convergence. So the interval of convergence, x needs to be in the interval from the center minus the radius, 0 minus 1/3, to 0 plus 1/3, which of course you can simplify as, a little bit more room here, x needs to be in between negative 1/3 and positive 1/3. So that would be what we're looking at as our answer for the interval of convergence, or all x's, where all x's, the x's were this series converges. No need to test the endpoints again because this is a geometric series that is preferable. That is what we want to see, and that's our question 1.